Next component I want to talk about is the thermostatic expansion valve. Now this is abbreviated TXV, X for expansion, or TEV, E for expansion. It depends on who you're talking to, but don't get confused. If you see TEV versus TXV, it's the same thing, thermostatic expansion valve. It is a metering device. It restricts a high pressure liquid to a low pressure saturated mixture through its distribution tubes to multiple points in the evaporator coil. This one is going to adjust though. It's going to open and close. It's going to change the size of the hole to account for changing conditions in the system. So let's talk about a few things that we have. We have the refrigerant entering on one side and exiting on the other. We have these other two pipes here. Let's talk about this pipe first. This pipe is mounted to the suction line here on a refrigeration cycle or somewhere here on the actual unit. It's in this component is a sensing bulb that has refrigerant in it. Right now this isn't hooked up, but there's still refrigerant in this bulb through this transmission tube and even in the power head. It's its own isolated refrigerant. As I heat this bulb up with my hand, the temperature goes up and the pressure goes up. The pressure pushes more pressure on this power head, forcing that valve open. When the temperature drops, the pressure drops, and a spring allows this valve to be pushed back close. Also, this has a side port. This is called an equalization tube. What it's doing is measuring the suction pressure on the same port, or example right here. It's converting that suction pressure to a saturated temperature. What that's doing, if you think about it, it's monitoring the saturation temperature or that pressure at the exit of the evaporator coil. So let's think a little bit more about what this guy's doing. It's measuring the actual suction line temperature, and it's measuring the suction saturated PSIG converted temperature. This guy's measuring superheat. But even more than that, it's not just measuring superheat, it's actually adjusting to try to maintain superheat. A lot of people call these a constant superheat valve because assuming that we have the correct amount of airflow and assuming we're feeding it the proper amount of refrigerant, this thing will maintain superheat for us. If the conditions change, it's adjusting and keeping the saturation level in the evaporator coil the correct amount. The conditions change again and it adjusts and keeps the superheat the right amount. We keep the correct amount of refrigerant in that evaporator, which is fantastic. It's absolutely awesome. What's even better is because it's doing this for us automatically, we don't need return air wet bulb, outdoor dry bulb, we don't need this chart, we don't have to worry about that at all. This metering device is automatically controlling it. Let's think of it like cruise control. With this is cruise control. We want a 15 degrees superheat, it's going to maintain 15 degrees superheat, regardless of what the outdoor temperature is doing and the indoor temperature is doing. We have to make sure we're feeding in enough refrigerant. We got to make sure we have the proper amount of airflow in the evaporator. But other than that, it will do that job for us, which is absolutely awesome. Let's think about cruise control. This is a car, and we're in cruise control. We're going up a hill. It gives it more gas, so to speak, and allows us to keep the same speed. We're going downhill on the other side. It backs off, gives it less fuel, so we try to maintain the same speed. We put more people in the car, same speed. Less people in the car, same speed. Headwind, tailwind, doesn't matter. This fixed orifice metering device right here is like screwing a board to your gas pedal. You're going up a hill, you're going to slow down tremendously. You're going down the other side, you're probably going to wreck. You're going to high speed tail in it. You put more people in the car, you're going to slow down. Less people in the car, you're going to speed up. Tailwind, every condition affects this. This guy adjusts, opens and closes to control the amount of refrigerant into that evaporator coil, which is fantastic, right? I mean, its job is to maintain superheat, assuming we give it enough refrigerant and the proper amount of airflow. So I really do love these metering devices, and unfortunately, they are misdiagnosed all the time. People say that this component's bad when they don't have enough airflow. People say this component's bad when they're not giving it enough refrigerant to do its job. Also, the other thing that causes these to fail is people abuse them. This particular one's a threaded fitting, but too many times they're brazed, and people will be brazing, like right here in this connection, with very high temperature oxyacetylene, and that temperature moves to these moving parts, and it breaks the moving parts or bends them. And what will happen is they don't fail right away. It's usually a few weeks, a few months, even sometimes a few years later before those moving parts being bent finally wear out. The other thing is this sensing bulb is mounted on the suction line. So somebody will go and braze on this suction line, and all that heat goes to this very sensitive sensing bulb. That caused this to overpressure, and it damages that diaphragm inside of there. So installation is the biggest cause of damage. Also, when we do brazing, and we'll be doing this later, we're supposed to purge nitrogen through these lines while we braze. It prevents oxidation, which is a type of soot inside the lines. People that don't braze with nitrogen all that oxidation, all those contaminants get hung up inside this metering device. So people say, oh, these are junk, I replace them all the time. So far I've found that people that replace these all the time are either overheating them with their torch, they're not protecting the valve, they're overheating the sensing bulb, they're not purging with nitrogen, or they're not pulling a good vacuum. All these things we're going to talk about later, but they are killed. They very rarely go bad. They're usually being killed. So it's a very simple component. Now, if the system is new, it's usually pretty easy to install a TXV. Now, once the system's already running, it's kind of a pain to work on it because you got to pull all the refrigerant out to convert it over. But let's look at what's involved in converting it from a fixed orifice to a TXV. So first we're going to have our metering device in this connection. We unscrew the connection, we take our fixed orifice metering device, we get rid of that, and then we take our TXV, and it already has the threads on it. So it just threads right into that very same spot. And we take this side, we want to make sure the seal is good, that Teflon seal is good, we thread it into the other side. Then we mount this on our suction side. There's usually already a port there for us. Sometimes we have to braze one in. And then we take our sensing bulb and we read the instructions and we put it exactly where it wants, which is usually 10 and 2. Sometimes it's a little different location. But we mount the sensing bulb with the clamp and then insulate it so it's reading the temperature of that suction line. It's quite simple. Simple metering device. When you install it correctly, works fantastic. These have been around for many, many years. I've seen these over 30 years old working like they were brand spanking new. Sometimes they do fail. Everything made by man fails at some point in time, but they are really great metering devices that are misdiagnosed all too many times.